This is what 3 years of trying to improve Division looks like.
Tough matchup for both spots. Division with a big hit right off the bat. Fast spin-up time for Division. Is Division able to self-right though?
Yes!
Yes, they are!
Holy cow!
Oh, nasty hit there from Link, but Division landing right on their wheels.
Oh, it looks like Division might, lost one of its wheels on its left side.
Oh, nasty! Yeah, the wheel is gone. And now the other wheel is gone, and that...
I have gone through so many revisions of every single part on this robot, and I keep having the same problems over and over again, and I'm sick and tired of it. There's something that has to be done to make Division more reliable, and that is to get rid of these pieces of crap. You might have noticed from that intro shot, a lot of these pieces look quite a bit alike. That's because this drive mount part has been the bane of my existence since I switched to a Division version 3 platform at the end of 2021. I have struggled so many times to figure out what the best combination of materials and print settings is for this thing. Just in this pile alone, there are drive mounts printed in Ally 910 nylon, PETG, PLA, eSun nylon, Matter Hackers nylon, polycarbonate, I think I experimented with at some point, carbon fiber nylons, and more, and even polypropylene. And I just cannot seem to get this part to hold up to the forces needed to withstand a direct wheel hit. Now, I don't actually have an example of the current Division drive pod, so this is one of Shrapnel Mine's drive pods, but it's assembled the exact same way as Division's, so going over the process of how it goes together is completely identical. Division is currently in a bin somewhere, I think at NHRL, where it will probably be sitting until the August Norwalk event because it was driven there at the end of Open Sauce in a box with all of my along with all of my tools. So I probably won't be touching it whatsoever between now and the August Norwalk event. So make sure to subscribe and hit the bell icon so you get notified when my Open Sauce recap comes out, because at Open Sauce, Division had all the same upgrades that it'll have at August Norwalk. And I'll talk about what those are throughout this video. This is one of the drive pods that is on Shrapnel Mine, and like I said, it's pretty much identical to that on Division. The basic idea is that you have a relatively low kV brushless motor, small gear on the motor, big gear on the wheel. There is, in the latest version of this mount, a zinc woodworking threaded insert that goes into the back here, and then a long steel shoulder bolt comes in from the front and acts as a dead axle, and then a brass bushing is pushed through both the wheel and the gear to support them all on that shaft. So the shaft just threads into the insert back here, and assuming that I thread the insert in all the way, there should be a tiny, tiny amount of play, and I can adjust that with some shim spacers so that the wheels spin more or less evenly. So it's a little bit less than a 5-to-1 reduction. That said, with the 4S LA HV battery that I use in Division, it was still geared for about 35 miles per hour at full throttle. So I needed to make some changes to address that. One of the changes that I made was this. I commissioned custom motors to be made with a lower kV. So this is a 1000 kV motor, which you can buy at justcauserobotics.com. And this is essentially the same size motor that you see here, but with the lower kV, so I get lower RPM and a bit better throttle response at lower percentages. This made Division a little bit more drivable, but with only a 5-to-1 total reduction and such a high top speed, it's still borderline impossible to control It's very twitchy because sensorless brushless startup is never perfect. So you push forward on the stick, one motor might start slightly before the other, it doesn't actually go in a straight line, and a whole host of other problems a result of that. After doing all of these different revisions of this drive mount, trying to get brushless to work properly, I realized I kept clawing more and more weight away from the rest of the robot to try and make that more robust, until I got to the point where, really, was I saving any weight at all at this point with using this setup compared to just a traditional gear motor? I mean, this whole drive pod right here from Schrappelmine is 116.6 grams. Now, these wheels are a bit bigger and heavier than Division's wheels, but still, that's a lot of weight. Now, a version of my DartBox gear motors, this is the 6mm shaft. This guy right here is 56.6 grams. And if we add in, let's say, an SSP wheel and wheel hub, and then a way to mount it to the robot, we're still at or below around the same weight. Now, on Division, I had this setup being a little bit heavier than the previous setup, but that was okay. I was already a few grams underweight in my heaviest config, so I was able to basically run with this and a few other modifications to allow me to run a setup like this. Let's talk about another robot. This is an SSP, or one of my personal SSPs, but essentially one of the archetypes for the SSP kit that I sell. In this robot, we have 4mm shaft DartBox Dragon motors going directly driving the rear wheels with a belt to the front wheels. Now, this setup has proven to be extremely reliable. I still haven't had a motor break in any of the fights that I've had with SSP personally. And having a single drive motor or two drive motors go through dozens of fights is pretty nice. So I didn't think that they were necessarily going to break if the motor shafts weren't taking direct hits, even with the 4mm shaft. These squishy rubber tires, even when they do get hit with the TPU hubs inside, they kind of help to isolate shock from the motor shaft. And that's really important for making sure that they don't break. Another thing that I do in SSP that works really, really nicely, and which I've kind of copied here, is that the UH&W chassis cradles not just the gearbox, but the motor itself. This is very important because the connection point between the motor and the gearbox is going to be a problem. If you face mount these motors, you've got all this weight hanging off the end. There's only 2 mounting screws holding this motor in place, and they're M2 mount screws. You really don't want to be relying just on that. Now, with some of the other round options, people will heat shrink over this, or you could even, on these motors, you could add a bead of epoxy around here to strengthen that joint. But a lot better option is just to add a physical support that touches the motor with some sort of a soft cushioning material, like, I don't know, the UH&W chassis of an SSP kit, or in this case, a 3D printed TPU mount. This, plus a sandwiched piece on top that also has mating interface, shock isolates the motor. So even if the shaft takes a hit, instead of this being rigidly mounted to 3 pounds of robot with all the inertia that a 3-pound robot has, it's got a little bit of wiggle room to move, to absorb some of that energy before the shaft would just bend or it would just mulch all the gears inside the gearbox. Granted, I still want to avoid the shaft directly getting hit, so future versions, I'm going to have wheels that kind of stick out past this, and I'll cut the shafts shorter so that the wheel is taking the hit instead of the shaft. Now, the astute among you might be wondering, well, you've got your brushed gear motor instead of brushless, so surely you need a different speed controller, and that is correct for the most part. I do need different speed controllers to run these motors than I was previously using for Division's drive. Previously, I was using BL Heli 35 amp Hack RC speed controllers running BL Heli 32. Now, these brushed motors can't be driven with a BL Heli 2 speed controller or any brushless speed controller off the shelf because they have a 2-wire brushed motor interface, not a 3-wire, 3-phase brushless motor interface. I sell on my site some dual speed controllers that work great for driving 2 brushed motors, and this is what's used inside of SSP here. to drive both motors, and it has onboard mixing and a few other nice features, but I could never fit one of these in Division. It's just too space constrained. And these things are kind of big and heavy. I mean, they also are really cheap. Just one of these costs about as much as one BL Heli speed controller, even though it can drive 2 motors. So I needed another option. There are, however, some nice, small, single brushed motor speed controllers, like this BBB ESC sold on the Bristol Bot Builders website. However, I have beta versions of these, and when I tried getting them to work with Division's electronics, I just could not stop dealing with some weird jittery behavior, and even working with the guy who designed them, I wasn't able to solve that problem. But I forwarded all the information I could to him, and I think that he'll be able to work that out in future non-beta versions of these. Either way, though, I needed a solution right now. So what I'm actually using is brushless speed controllers. But wait, you can't use a brushless speed controller to run a brushed motor. But actually, you can. This is a 45 amp rated brushless speed controller. However, what makes this speed controller different from the BL Heli ones that I use in Division for Drive previously is that this speed controller has a different firmware called AM32. AM32 is a relatively new speed controller firmware, and it was designed originally for use with brushless motors, but Peter, who designed and wrote most of the code for the AM32 firmware, wanted it to be flexible. When you're controlling 3 motor phases, you need 3 sets of FETs, but if you just don't use 2 of the FETs, then you've got a 2-phase controller, which is perfect for controlling a brushed motor. So there's no reason that the hardware on a brushless speed controller can't control a brushed motor. It's just a matter of firmware. But fortunately, AM32 firmware does run on these tiny sensorless speed controllers, and it works just fine. And while it doesn't have quite as convenient of a way of switching to a brushed mode, you can flash a brushed AM32 firmware on these and get them to run with just 2 of the phases, any brushed motor, perfectly fine. So inside of Division, I don't have this exact speed controller, but I have an Flash Hobby AM35 speed controller running AM32's brushed firmware, and that's actually been working great to run the brushed motors. And the nice thing is, if I decide I want to use it for an ant-weight weapon later, I can just flash a brushless firmware onto it again and use it again, and all that you need to do that is an Arduino USB linker, or even the same DYS V2 linker that I use for BL Heli programming in my BL Heli speed controller videos. If you want a tutorial on how to change the AM32 settings, let me know in the comments and I could make one. You just need to grab a firmware file from the AM32 GitHub, and you'll find it as Alka Motors or AM32, and you can just find you plug this into your computer with the USB programmer, identify what firmware is on it, find the name matching brushed firmware of a similar version number, upload that, and it should work just fine. And you can always go back to brushless. It's still in active development, and there's even an AM32 Discord. If you have any questions, you should definitely join it, and you can talk to the lead developer, Peter himself, and he will helpfully answer a lot of questions. He was very helpful for me getting started with the AM32 myself as well. Now that we've gotten the electrical integration out of the way, let's talk more about the mechanical integration and how I had to modify Division's chassis to make this thing fit in there. Now I'm going to go over to a CAD view because I don't have the physical robot with me, so let's over to my PC now. Awesome, just recorded like 5 minutes and then realized that my microphone wasn't set properly in OBS, so none of the audio exists, so take 2, I guess. Alright, so I'm going to skip the comparison for the most part, but this is a comparison of what the brushless and new brushed setups look like, and you can see that the one advantage that the brushless setup had was that it doesn't stick into the chassis as far, so these are lined up with about this line being where they hit the edge of the chassis. You can see the wheel sticks out a lot less, but the motor sticks into the bot a lot more. This was one of the main motivating factors behind the brushless design originally, was how little space I already have in Division, and this eliminating a bit more of that. I added this little guard here to make it so that the wires and stuff are kept inside, and you don't have, like, I don't know, for instance, mixtapes flamethrower flames going straight into the robot, but basically was to take up more of this length than as this used to. And overall, these setups ended up pretty similar on weight, but I think the brush drive is still a few grams heavier. So here it is in context on the robot. Now my Space Mouse is kind of freaking out, so bear with me here if it goes off a little bit. I'll try to prevent my little webcam view from blocking too much of this. But this is essentially what Division version 3.5 looks like. Now you'll notice I added these wings on the sides of the lid to accommodate the wider motor mounting. And you can see those printed guides don't quite follow that, but this is more of just an aesthetic choice, really. It doesn't really matter for functional reasons. Over on the back, there are some mounting screw locations that interface through the back a tiny bit with the TPU, but it's mostly held in with screws from the bottom. So I had to add holes to the bottom of the chassis, here, 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 and here, and same on the other side. These other holes already existed there from the old brushless drive mounting. To do this, I 3D printed some drill guides, and I basically lined them up against the back of the chassis that exists from the top side, drilled through with my cordless drill, and then countersunk the bottom sides a little bit so that the screw heads weren't sticking out so much, more than you see here, but this is just to illustrate the difference between which holes were there before and which are there after that modification. Now I only actually did this modification to one of my Division chassis, not to both, so currently I have one brushless Division and one brushed Division in a bin at Norwalk, and that was how I competed with them at OpenSauce, but I was able to repair the brushed version only and keep that running through all of the fights that it had at OpenSauce. Make sure that you subscribe and click the bell icon to get notified when I release my OpenSauce event recap. It was pretty fun, and William Osmond got to drive Division for a couple fights, which is awesome as well. But yeah, that's pretty much it. So I got the brush motors in there, and got some new lids, got TPU printed parts, sandwiched them together, bada bing bada boom, you now have a brush drive Division where it used to be brushless. It drove so much better than the previous brushless drive.
Alright, here we go! 5, 4, 3, 2, 1, fight, robots, fight!
Box rush by William Osmond, out of the gate.
Hey, don't turn your thing.
Millions of subscribers on the line.
Ready?
Alright, he's retreating, giving Nile Red a little bit to, get his bearings.
You call that the right?
And they're ready to throw this thing down. Alright, here we go! And 5, 4, 3, 2, 1. Okay. Play, robots, play!
Nice!
Let's go!
Yeah!
3D printing.
Nice, you got him.
3D printing turn. That's what I just said.
I heard that!
2, 1.
Fight, robots, fight!
And it has proven very devastating. Oh, energy! Just like that big hit, and not dead yet, is hanging out up against the pink plate. It's a big hit out of Division.
Saying you can use your own stick work. I did really well.
So this is
Push him!
A little lift there, coming from Styro.
Yeah, there you go!
Together, yeah!
Nice!
James is on his head right now.
Editing, Seth here. Just realized I forgot to shoot an outro for this. If you check links in the description, you'll be able to download the CAD models for both Division's previous brushless drive system for free on my site, and there'll be a paid link for downloading the shock mounting TPU that I have for the current version as well, as a standalone model, so you don't have to pay the whole $25 for the full Division CAD, though that's available as well. So check out links down below. I'd also like to say you should definitely subscribe and click the bell icon so you get notified when all of that footage from OpenSauce comes out. Hope you enjoyed that little preview here, and I should have a video about Division's time at OpenSauce and all those creator fights out in the next few weeks. That's all I've got for you today. Thanks for watching.